Let's start with ethane molecule. This portion can be marked as a substituent methyl. The whole thing can be marked as a substituent of ethyl, CH3CH2, or you can write C2H5, right? So any of these substituents can be R if you consider this hydrogen as a substituent connected hydrogen. So that means hydrocarbons are actually RHs, okay? Now that's a good way to think. Now what we can do, we can replace that unique H with an OH group, hydroxyl function. So then you should write ROH instead of the RH hydrocarbon. Similarly, you can put double bond CO, double bond COH for carbonyls, and also you can add an extra OH making hydroxyl groups, right? So in order to see this connection, it's a good way to think reduction and oxidation. Most reduced hydrocarbon is CH4, and this would be the left end. The right end, the most oxidized carbon is CO2, carbon dioxide, right? So it's a good way to rank these molecules, which is reduced and which is oxidized. So you have to compare with something else, right? Now, regarding naming, alcohols, this one will get 2 carbons, it's ethanol. So you can kind of change the, cross the name at all so you can see what it is. Similarly, these carbonyls can be named as, the top one is propan-2-on actually, and then the bottom one is Ethanal. So you can draw a line to see the difference, right? And then the last one, Ethanoic, is 1,2 carbon ethanoic acid, but this is also common names acetic, and it's what's the ingredients in the vinegar, right? So I'm just putting a square to the IUPAC names, and ethane, ethanal, propanone, and so on, right? Now there are 2 unique ones you want to compare. So that is when you have amine. Amines comes from ammonia. So if you cancel one of these hydrogens and stick to a hydrocarbon R, then you get an amine, okay? So this one should be labeled at methanamine. So you can put a separate line between the 2 names. You can read it and understand. Now, if you have a CONH2, that's an amide group. And this is the amide functionality, 1, 2, so it's ethanamide.